So, good evening, all of you. Today, we will discuss part B, which is similarity and dissimilarity in feedback of our first internal of data science. So, let's start. Our first question is briefly outline how to compute dissimilarity between students' feedback profile and describe by. So our first question is a normal attribute, which are department and elective chosen. So for normal attribute, dissimilarity can be computed using the simple matching, coefficient, or complementary approach. So the formula of this is T equal to P minus M by P, where P is the total number of attribute and M is the total and M is the number of matches or agreements. Alternatively, we using Jacquard distance for better interpretation, d of Jacquard is equal to 1 minus number of matches upon total attributes. For example, if a student's department and elective chosen match in one out of two attributes, the dissimilarity is 1 minus 1 by 2, which will be half. So next is asymmetric binary attribute. For asymmetric binary attribute, where yes is more significant than no, use Jacquard's coefficient uh, for the asymmetric is equal to t upon a plus b plus t. Here a is number of attribute where profile 1 has yes and profile 2 has no. B is number of attribute where profile 1 has no and profile 2 has yes. And D is the number of attribute where both have no. So the matching yes cases are excluded from the denominator to emphasize their significance. So our third question is numeric attributes. For numeric attributes like CGP and attendance percent, we use Euclidean distance, Manhattan distance, or Moncovet distance. The choice depends on the distribution and domain knowledge. So this is the formula of the Euclidean, which is under root summation of xi minus yi to the whole square from I equal to 1 to I equal to n. And the Manhattan is a summation of mod xi minus yi from I equal to 1 to n. For heterogeneous data set, we normalize the numeric values attribute to 0 to 1 range before computing the dissimilarity. And for term frequency vector, for open text feedback, represent as term frequency vector. Use cosine distance or cosine similarity converted to distance. The formula of distance cosine is 1 minus x in x dot y upon mod x mod y. Or we can also say that. So let me check. So this is the formula of the cosine. So where x and y are the term frequency vector. Alternatively, use Euclidean distance or normalized TF vector or TF-IDF vectors for better results. So next question is: suppose two students faculty interaction profiles are represented as tuples, uh, 22, 1, 42, and 10, and 20, 0, 36, 8, where attributes represent hours spent in mentoring, project reviews attended, third is assignment submitted, and in infrastructure usage count. So we need to compute these four things. First is Euclidean distance, second is Manhattan distance, third is Moncoing distance with age equal to 3, and fourth is supremum distance. So, so let's start. So I need to open my PDF of solution. So here is our solution. Uh, for Euclidean distance, we have formula which is T of Euclidean is equal to under root summation of P1i minus P2i to the whole square from I equal to 1 to I equal to 4. This is the formula. And here we have values. This is for P11, P12, P13 and P14. Similarly, these values are for P21, P22, P23 and P24. So after putting all these values in formula, we get Euclidean distance is equal to under root 43 or 3 root 5. So next we need to find is Manhattan distance, or we can also say taxi cab distance. The formula of this distance is summation of mod of P1i minus P2i from I equal to 1 to I equal to 4. So after putting the values, seventh last question, we will get the Manhattan distance is 11. So we will, so our third is a mean cosine distance with h is equal to 3. So for this distance we have formula, uh, summation of mod of p1i minus p2i to the whole power 3 from I equal to 1 to I equal to 4 with the whole power of 1 by 3. Here we can see this. After putting all the values in this, we will get distance for h is equal to 3, 6.15 approximately, or 223 to the power 1 by 3. For supremum distance, in this distance uh, we select the maximum difference. So for supremum distance, the formula is maximum of P1i minus P2i. So the values are that maximum of 2162. So the maximum value is 6. So 6. So here the supremum distance will be 6. So finally, you can say that Euclidean distance is 3 root 5, which is approximately 6.708. Manhattan distance is equal to 11. Minkowski distance equal to 233 to the power whole 1 by 3, or approximately 6.155, and supremum distance is 6. So let's move to our next question, which is question number 7. We have a question number 7. Question number 7. The median score of The median score of often a key holistic indicator of faculty infrastructure performance. When dealing with massive students' feedback dataset, propose methods for median approximation, analyze their complexity and suggest heuristic to balance the accuracy versus efficiency. So basically we have four methods propose the propose the median approximation are: first is sampling based approximation, second is quantile sketch algorithm, third is partition based approximation, and fourth and last one is histogram based approximation. So let's start with the approach of first method, which is sampling based approximation. So for this, we draw a random sample of size k from the dataset, compute the median of the sample, and use it as an approximation of the population median. The complexity of this approximation method is big of k log k, and the accuracy trade-off is the larger the sample size, the higher accuracy and higher cost. For a small sample size, the accuracy will be lower and the computation is faster. So our method 2, which is quantile sketch algorithm, also known as T-digest and KLA. So approach of this method is use streaming quantile sketches that maintain approximate quantile information without storing all data points. The complexity of this is big O of n for insertion and big O of log m for median query, where m is sketch size. For if we talk about this accuracy, for I it's typically within 1% of true median. Its accuracy is high. For advantages, it handles streaming data efficiency, low memory footprint, and parallelizable across data partitions. So our method third three is partition-based approximation. The approach of this is to use randomized selection algorithm to find the median without full sorting. expected complexity is big of n, and the worst complexity if this approximation is big of n square. And the heuristic to balance accuracy use iterative refinement, partition around a random pivot with median not yet located, recursively partition the relevant half, and third is use early termination, use sufficient accuracy is achieved. Method for which is histogram based approximation. The approach of this approximation is build a histogram of feedback scores, then compute the median of the histogram beans. Complexity is big of n plus b, where b is the number of beans. And here we can see the comparative complexity analysis of all the methods. So for sorting, the time complexity is big of log n, space complexity will be big of n, accuracy 100%, and streaming, and there is no streaming. For sampling, the time complexity is big of root n log root n, space complexity will be big of root n, accuracy around 85 to 95%, and no streaming. And more information you can read on this table. So let's move to our today's last question, which is question number 8. So question number 8, consider student faculty similarity analysis. A sample data set of two attributes, which are faculty responsiveness and infrastructure support, is provided. So let's start. First question is computing similarities and ranking. आपको तो यहाँ पे हमें 5 स्टूडेंट्स के फीडबैक स्कोर दिए गए हैं, जिनमें 2 एट्रीब्यूट्स हैं। पहला है फैकल्टी रिस्पॉन्सिवनेस और दूसरा इंफ्रास्ट्रक्चर सपोर्ट। सो यहाँ पर हमको चेक करना है कि कौन सा स्टूडेंट क्वेरी के सबसे सिमिलर होगा for computing similarities and ranking. So we have 5 student profile, tuple of faculty responsiveness and infrastructure support. So we can write all the values. These are S1, S2, S3, S4 and S5. So for Euclidean distance, we know the formula of Euclidean distance, which is xi, x1 minus si to the whole square plus x2 minus si2 with the whole square. So let's find all the values. So for dx comma s1 is uh, approximately 0.412. For dx x2 is equal to approximately 0.67. For s3 it will be 0.283. For x4 it will be 0.224. For x5 it will be 0.608. So in Euclidean distance, the similar distance is equal to, the smallest distance is equal to most similar. So we can see that the smallest distance is 0.24, which is of S4. So the most similar point will be S4. S4 is the most similar. So let's move to the second, which is Manhattan distance. The Manhattan distance is x of x comma xi is equal to x1 minus xi1 plus x2 minus xi2. And similarly, we find all the results using this for above formula. Here you can see this highlighted area are results. So the on the basis of above result, on the we can give ranking to that S4, which is 0.3. S4 of 0.3 is less than S3 of 0.4, which is less than S1 of 0.5, which is less than S5 of 0.7, and S2 of 0.9. And for supremum distance, we take the maximum value. So the answer of this question will be zero point 0.6, which is the maximum from all among the values. And similarly, we will move to cosine similarities. Cosine similarities angle between vectors. If the answer will be 1 or near to 1, it will be very similar. So here we have find all the values. So which the value S4 is nearer to 1 among all the values, and S3 also. So the cosine similarity angle is for S3 and S4 will be good. So cosine distance ranking for smallest distance equal to most similar. Cosine distance is equal to 1 minus cosine similarity. So these all the values are cosine distance ranking. So we can rank that in this manner. So here we wrote that S3 is equal to 0.001 and S4 which is also 0.001. So the best so these two results are the best for cosine similarity. For summary table, we have four methods: Euclidean, Manhattan, supremum, and cosine. So after giving ranking, like for Euclidean, we will give rank 1 to S4, rank 2 to S3, rank 3 to S1, and rank 4 5 to S5 S2. Similarly, we can read the ranking of Manhattan. So rank 1 is S4, rank 2 is of S3, rank 3 is of S1, and rank 4 5 is S5 S2. For supremum, S3 and S4 have same distance or same maximum values. So rank 1 is of both, rank 2 is of S1, and rank 3 is of S2 and S5. For cosine S3 and S4, here we see this that the answer is 0.001, which is nearer to 1. Sorry, which is nearer to 0. So rank 2 is S1, rank 3 will be S2, and rank 4 5 will be S5. So let's move to our part B of question number 8. So part B is normalize Euclidean distance. So part B is normalize each student's vector to unit length and recompute using Euclidean distance. तो पार्ट बी में हमें एक एडिशनल स्टेप इंट्रोड्यूस करते हैं. हर स्टूडेंट वेक्टर को नॉर्मलाइज करके फिर यूक्लिडियन डिस्टेंस कंप्यूट करते हैं. सो स्टेप वन इज नॉर्मलाइज स्टूडेंट्स वेक्टर. Here we are normalized the student vector. So S1 vector is 0.6, 0.8, S2 0.725, 0.689, S3 is this, and S4 is this. So for the all normalized values are here, and for S5 this is. After computing Euclidean distance or normalized vector, we will get d of x vector x1 is 0.005. For S2 we will get 0.00859. For S3 we will get 0.00006, and for X4 we will get 0.00178, and for this we will get 0.06. So for the normalized Euclidean ranking is S3 less than S4, less than S1, less than S2, and S5. This is the result of our question. So thank you so much for watching my video.